In today's Physics in 5, we want to describe motion. How do we know if something is moving?
So, did motion take place?
Well,
What do you observe in this environment? I would argue that motion did take place, but did you see it take place? And that's oftentimes when we say, how do we know something is moving? It's more arbitrary than just, oh, I saw it move down the road. Even if you see an object moving, you're looking at it in reference to background information. So for example, you could theorize that I moved from over there to over here because the screen is still in the same place. So that's the easiest way to tell if something is moving is in reference to other things. And so we have to have a background or a reference point to take all of our measurements from.
in this frame of reference, clearly these lab coats stayed in the same place. However, the bodies inside moved. I would say I moved 2 meters to the left.
But I started over there, so I would have moved about 2 meters as well, but I moved to the right. And so that's another critical thing that we're going to look at today, is that when we talk about motion, it's not simply how far or how fast. It also matters what direction that is moved. Because if I was over there and also moved 2 meters to the left, well, I would just simply not be in camera shot anymore.
So direction is an important piece that we need to include when we're making a measurement. And this is what helps us to know the difference between what we call a scalar and a vector. A vector is a measurement that has some amount and a direction.